Hi, so we did our project on hydrogen cars. We're students at the University of Houston in Dr. Bott's Chemistry 1301 class in the summer of 2015. Our group members are Dahlia, Christina, Nura, and Farron. So the history of automobiles. In 1769, Nicholas Joseph Cugnot developed a steam-powered engine tricycle. It traveled at 2.25 miles per hour and had 4-passenger seating. The engine powered for approximately 15 minutes before needing to restore its energy to function again. Next, Carl Friedrich Benz, who lived from 1844 to 1929, created the first gasoline-fueled internal combustion engine. It had a 3/4 horsepower engine. The engine type was a 4-stroke engine. Its maximum speed was 8 miles per hour, and it was a 3-wheeled automobile. This vehicle weighed 584 pounds. So Gottlieb Daimler, who lived from 1834 to 1900, created the world's first 4-wheeled automobile. It had an internal combustion engine and a 4-stroke engine. Modern gasoline-fueled vehicles. Over the past 5 years, ranging from 40 to 60 million cars have been produced yearly. Some of the best-known manufacturing vehicle companies in the USA are BMW, Fiat, Ford, Honda, Mazda, Nissan, Volkswagen, Toyota, and many more. The fastest car in the world is the Hennessy Venom GT. This vehicle has a traveling speed of up to 270 miles per hour. Approximately 250 million personal vehicles are registered in the USA today. As a nation, we consume about 378 million gallons of gasoline every day just for automotive transportation. So this part of the little movie here is going to explain the fraction distillation process. So what happens here is crude oil is heated up to different temperatures depending on what type of product they're wanting to get out of it. So first, at 350 degrees Celsius, residue is going to be produced. And this product is going to be used to create things like roads and cement, etc. Next is going to be fuel oil, and this is produced at 310 degrees Celsius. This is commonly used for big barges or ships, cargo ships, and other types of large boats. So next, at 270 degrees Celsius, it's going to be diesel oil. Diesel oil is used for large 18-wheelers, trucks, commercial vehicles, etc. And next, at 170 degrees Celsius, is kerosene. Kerosene is used for commercial airlines and other aircraft. At 120 degrees Celsius, naphtha is made, and this is used to produce different types of chemicals. At 70 degrees Celsius, some people like to think the most important of them all is gasoline. And this is used for our everyday transportation in our sedans and two-door coupes and etc. Next, at 20 degrees Celsius, refinery gases will be created. And this is going to make things like your propane tanks and other things like that. So now if you look at the arrow on the right side of the screen, the blue and red arrow, it's going to explain how these different gases compare to each other. On the blue end, the ones that are made in cooler temperatures are going to be your smaller molecules. These typically have lower boiling points, lighter color, and lower viscosity. And on the hotter end are your larger molecules, which have a higher boiling point, a darker color, and an increased viscosity. So this is the reaction that produces gasoline. It's an exothermic chemical reaction. It's made from C8 H18 and O8 combining with CO2 and H2O, which is going to be octane and oxygen combining to produce water and carbon dioxide. This reaction is an exothermic combustion reaction. And this chemical equation is the process when oxygen reacts with an element or compound that produces oxide and heat. Heat is a form of energy that supplies the motor engine to ignite. So the history of hydrogen vehicles. In 1807, Swiss inventor Francois Isaac de Rivaz designed the first hydrogen internal combustion engine that ran inside the first automobile. This first four-wheel prototype used hydrogen gas and oxygen as fuel. It stored compressed hydrogen gas in a balloon and had an electrical volta cell ignition. In 1860, French inventor Etienne Lenoir invented the one-cylinder two-stroke hippomobile, which received its fuel by electrolyzing water and running the hydrogen through the small horizontal engine. Next, in 1933, the Norway Norsk Hydropower Company converted a small truck to run on hydrogen gas. It carried an ammonia reformer that extracted hydrogen and then burned it in its internal combustion engine. In 1941, a World War II military technician, Boris Schelisch, converted a 200 GAZAA trucks in 10 days to run on hydrogen and demonstrated that they burned cleaner and longer than those that had run on gasoline. And this is the same idea that continues today, that people can hope that hydrogen will be a cleaner and more sustainable energy for our vehicles. In 1959, Harry Carl Ehrig converted an Alice Chalmers farm tractor, creating the first fuel cell vehicle. This tractor contained 1,008 tiny alkaline fuel cells and can pull up to 3,000 pounds. This tractor is currently on display at the Smithsonian Institute, and you can go visit it anytime you would like. In the next few years, in 1966, Roger Billings, as a part of a school science fair project, converted a Model A Ford to run on hydrogen. It had 2 compressed hydrogen cylinders and an internal combustion engine. The same year, General Motors created the GM Electrovan, which is considered the first hydrogen fuel cell car. It was powered by a 5-kilowatt Union Carbide fuel cell and had hydrogen storage tanks in the back of the van. In 1998, GM Opel Zafira fuel cell minivan was introduced at the Paris Motor Show as the first drivable fuel cell concept vehicle. It contained 2 25-kilowatt PEM fuel cells and used methanol with an onboard reformer. The next year, in 1999, BMW 750HL became the world's first automobile to run on liquid hydrogen. It was a dual-fuel vehicle capable of running on gasoline and hydrogen. It was a 5.4-liter V12 internal combustion engine. The same year, in 1999, the Ford P2000 FCEV became the world's first full 5-passenger fuel cell vehicle. It used compressed hydrogen gas and a fuel cell from Ballard. In 2001, Toyota FCHV5 Hybrid was the first SUV that used CHF, which is clean hydrogen fuel. An onboard CHF transformer extracted the hydrogen from the liquid fuel and ran it through the fuel cell to provide the power to the vehicle. The same year, in 2001, Chevy S10 pickup truck was the world's first drivable vehicle capable of extracting hydrogen from gasoline and using the H2 gas to power the vehicle. The next year, in 2002, the GM Autonomy was the first vehicle designed from scratch around a fuel cell propulsion system. It was the first vehicle to combine fuel cell technology with drive-by-wire technology. This is one of the most futuristic and sporty designs ever created for a hydrogen car. In 2004, the Hummer H2H helped Lax open the first retail hydrogen refueling station. In 2007, the Hiwit, developed in Denmark, was the first commercial hydrogen car offered to the public for sale at $37,000. In 2008, Honda's FCX Clarity started leasing to select customers in Japan and Los Angeles for around $600 per month. In 2014, which was only last year, the Toyota Mirai went on sale in Japan. The four-door family sedan is one of the first commercially available hydrogen fuel cell vehicles in the world and will be available in California in 2016 for $57,500. So the future of hydrogen vehicles. Hyundai Motor Company hydrogen fuel cell vehicles represent the future of eco-friendly cars more than any electric vehicles out there. On July 1st of this year, Toyota, Nissan, and Honda announced efforts to produce more hydrogen fuel cell vehicles and will all work together to build more fueling stations to support these vehicles. In California, 28 FCV stations are expected to be built by the end of 2016, bringing the state's total of stations to 48. Toyota has also partnered with First Element Fuel to build refueling stations in California, and with hydrogen fuel provider Air Liquide to build a network of 12 stations throughout Connecticut, Massachusetts, New Jersey, New York, and Rhode Island this year. So now I'm going to talk about how hydrogen cars actually work. Hydrogen vehicles are powered by a hydrogen fuel cell. Since elemental hydrogen is hard to come by naturally, the best source for hydrogen fuel is water. Hydrogen can be isolated from water via electrolysis. Electrolysis is the passing of an electric current through water that will break down H2O molecules. In the bottom left picture, you can see the electrolysis process. You can see in the blue and yellow circles is where the hydrogen and oxygen gas are being isolated. The oxygen is on the side of the anode because it is negatively charged, and the hydrogen is on the side of the cathode because it is positively charged. So then on the right, you can see a real-life picture of that happening, and you can see where the hydrogen and oxygen are being separated from the liquid. And you can also see where the battery is hooked up. I also have the equations listed for the anode and cathode reactions, and then also the overall reaction is going to be just water producing the oxygen gas and the hydrogen gas. So steam reformation is another way that you can isolate hydrogen. And how this works is it's going to separate the molecules of natural gas, and it separates the hydrogen from the carbon. And this is going to happen from methane gas, which is CH4. This is currently the most common method for producing large quantities of hydrogen, but unfortunately this process would not rid the need for fossil fuels because you are using methane, which is a natural gas, which is also used to make our current day gasoline. And you can see in the picture on the bottom the steam reforming process. So you're going to start out with that natural gas, which is CH4, and put it in the reformer. Then next, you will add steam, or H2O, and mix it in with the natural gas. And finally, step 3, you're going to add heat that will break apart the molecules. And next, the hydrogen and carbon dioxide molecules are formed. In step 5, the scrubber is going to remove the carbon dioxide. And finally, the end result is hydrogen that can be used for many purposes, including the hydrogen fuel needed to propel hydrogen vehicles. So this is how the engine actually operates. The hydrogen gas is stored in a high-pressure tank inside of the vehicle, usually underneath the car or in the trunk. The gas is passed through the fuel cell where hydrogen and oxygen is mixed to make an electric current. After the energy has been used up, the product that escapes the tailpipe is water. And you can see here in this picture that process occurring. You can see that the hydrogen is stored in the hydrogen cylinder, which is pumped full of H2 at your gas station. And that's going to move through the fuel cell, which will be moved into the motor to propel the car. After the process is complete, that will just come right back out the tailpipe as water. So much like electric cars, hydrogen vehicles also have a battery pack. And these are typically going to be for emergency situations like running out of hydrogen gas. The battery pack is used to occasionally assist with acceleration, but it is never used strictly for propulsion. The battery pack is small and rechargeable, and it can be recharged through regenerative braking and excess energy created by the fuel cell. So how regenerative braking works is while you're driving the car and braking to stop, as you're braking, the energy used in that process is put back into the battery to keep your battery fully charged. And this is also why it's never used strictly for propulsion, because it will run the battery down. But it can assist with the acceleration when you are low on fuel, but it will be recharged as you're braking. So this is how the fuel cell actually works. First, the hydrogen gas moves into the positive terminal of the fuel cell. The positive terminal is made from platinum, which is designed to work as a catalyst that makes the reactions occur more quickly. Next, the oxygen moves into the negative terminal as well. When the hydrogen gas reaches the platinum catalyst, the atoms begin to split up into ions. The protons are then attracted to the negative terminal and pass through the electrolytes, which are made from plastic. The electrons continue through the circuit, powering the motor that drives the car's wheels. The protons and electrons finally recombine with oxygen in the negative terminal, which creates a chemical reaction that produces water. Finally, the water product is given off through the tailpipe as water, vapor, or steam. The fuel cell will continue to operate as long as there is enough hydrogen and oxygen to fuel it. So electric cars versus hydrogen cars. Electric cars work off of battery-powered energy. They are renewable, they require little of no fuel, and there are more abundant recharging stations for them. So hydrogen is not actually an energy source. It requires fuel cells. It can be renewable, but also can be non-renewable depending on the source, like I mentioned before when I was explaining how the car actually works. Sometimes the process of making the hydrogen gas can burn fossil fuels, like I mentioned before. Pollution-free depending on hydrogen is produced. So if you are using electrolysis, this can be a very environmentally friendly process, much like electric cars. The pros of the hydrogen cars is that they are 3 times more efficient than gasoline, which is a pro in a society full of commuting workers. It has 0 emissions, which means it's environmentally friendly. It can run 3 to 4 times longer than the most capable electric cars today, which is very impressive because electric cars typically don't go more than 100 miles before you have to refill them. And like it mentioned earlier, the recharging stations for these are still pretty fair. And hydrogen stations only take slightly longer than a gas pump to refill, which is unlike the electric charging stations. Those are going to take quite a bit longer than the regular gas pump, and sometimes these can take up to several hours, especially if charging overnight. So the cons of hydrogen vehicles are that electric vehicles are at least 3 times more energy efficient than hydrogen fuel cell vehicles, which basically means that they utilize the energy that they actually have more efficiently. They are more expensive than electric vehicles because they are still new and developing. They can be highly flammable if impacted, such as in a car wreck. They can explode. They have lack of sufficient infrastructure for hydrogen refueling. So if you're out and about and you need to recharge, then you're kind of just out of luck because they haven't developed enough hydrogen gas pumps. They are bulky storage, and they are not completely environmentally clean depending on what way the hydrogen fuel is produced. So this is basically breaking down the hydrogen versus electric cars' energy efficiency, and it's just explaining how the energy is used within the vehicle. And as you can see, the electricity uses its energy much more efficiently than the hydrogen vehicle. So these are our sources, and thank you for watching our movie.